All right. In 3.1, we would have taken these two equations and graphed them and looked for where the lines intersect. Perfectly fine. Except for it would be nice to not try and kill ourselves drawing the perfect graph so that our solution will be exactly what it should be. Okay? So what we're going to do is find a better way. Or in the example of this problem, this x and this y are going to be rather large, and so to find their intersection point, we'd have to extend the graph off way over to one side, and so better than that, both so that we don't have the size and the accuracy limitations of graphing working against us. We're going to find a way to do this just strictly with numbers. Okay, so the first thing we're going to learn about is the substitution method. And the substitution method, in order to explain what that means, follow along with me now. Remember that a solution to both of these equations is an x comma y, where you can take the x, this x here, and put it in for that x, and put this y in there, and of course that'll be a solution. Both sides will be equal. But take the exact same x and put it here, and the exact same y and put it over here, and that will be a solution for this equation and for that equation. The same exact x and y goes in here and works for both. Okay, so we get that. That's important that we understand that's what a solution to a system of equations means. So now, in order to understand the substitution method, in this equation, you get y by doing this, right? So right now, kind of ignore all the stuff in red. That was just to say we know that we're going to use the exact same x and the exact same y. That's the important thing that you understand. Okay, for this equation, to get y, you're going to take something for x and put it in here, and you're going to do all this stuff. Okay, and that's how you find y. That's how y is found for this equation. For this one, you do this other different stuff to x, and that's how you find y. Okay. Essentially, what we want to do is we want to put the exact same thing in for x, do this to it in this equation, get out a y, do this stuff here in this equation, get the exact same y. Okay, so we know that y is going to be equal to this stuff in this equation, and y is going to be equal to this stuff in this equation, so we want this stuff to be the exact same thing. So we can substitute this y with this y, right? We can take this stuff here and put it in for that y. And let's see, we'll pick this color. No, let's just stay with this light blue. So what we'll wind up with is negative 2/5 x minus 1. We should be able to put in an x and get the same thing on this side as we do on this side using the exact same x, right? And this side is just negative 1/3 x plus 1. So we want to put in the exact same thing for x and get this side to be equal to that side. Well, what we've created here is a new equation. This equation doesn't have two variables, it only has one, and we can just solve for it like we have before, solving for the x here, get the x by itself. So we could add 1 to both sides, get negative 2/5 x equals negative 1/3 x plus 2. And we can add a third to both sides, so we'll get negative 2/5 x plus 1/3 x equals 2. We're going to need some common denominators here. We're going to have a common denominator of 15. Here, let me show you something here that'll be really cool. The common denominator of 15, let's just multiply both sides by 15. Okay, that means we're going to distribute this 15 here. 15 times negative 2/5 x plus 15 times 1/3 x equals 30. What happens here is the 15 cancels with the 5, and this will become a 3. So now we have 3 times negative 2. That's negative 6x. 15 times 1/3, those will cancel. We get 3 cancels with 15, and we have a 5. And on this side we have 30. Now we have no more fractions. That's the nice thing. So we have 5x minus 6x, that's negative x equals 30. And x would have to be then negative 30. Right, without having to do any graphing or guessing or anything like that, we got exactly that x is the, or negative 30 is the x value that you can plug into both of these and get the same y. Whether I put it here or I put it here, I'll get the same exact y. I mean, we need to know what that y is, so let's put that into one of these equations. It doesn't matter which one. This one's a little simpler, I think, so we'll use that one. So we're going to find the y value by plugging in this for x. So negative 1/3 times negative 30 plus 1. Negative 1/3 times negative 30 is going to be a positive 10 plus 1, and that gives us 11. So our solution will be negative 30, comma 11. That is the answer. This is not the answer. This is not the answer. This is the answer. Together, they are the answer. Negative 30, comma 11. That's the x and the y that we can put into both of these, and they both work. Okay. And next, we're going to use this system of equations. Let's go 8x minus 4y equals negative 32, and negative 3x plus 4y equals 12. Okay, and now what we're going to learn is the elimination method. What we're eliminating is one of these variables. We're eliminating either x, or we're going to eliminate y, so that the other is the only thing that's left. That's really the point of any of these algebraic methods, is to somehow make one of the variables obsolete, or just to kind of get rid of it in a way so that one variable is left, and it's easy to solve for one variable. We've been doing it for a long time. So the elimination method, as opposed to the substitution method, you'll see why it's called elimination, because we're going to get two of them to cancel each other out. Okay, and before I show you that, before I do something and it seems really weird and magical and not allowed, I'm going to show you that it is allowed. Remember that with any equation, you can do anything you want as long as it's the same on both sides. So I could take this top equation and I could add 5 to both sides. I could divide by 2 on both sides. I could take the square root of both sides. I could do lots of different things as long as it's on both sides. It's the exact same thing. So let's say I were to take this equation, and on this side I'm going to add 12. Okay, and it's no coincidence that this is also 12. I'm going to add 12. So I need to add 12 on this side as well, right? Let's see if I can write this really faintly. Add 12 on this side. But adding 12 on this side, the number 12 is kind of, it doesn't really help us out at all. But 12 is equivalent to this stuff over here. So we could instead, let's just erase what I've written there. Instead of adding 12, let's add its equivalent, which is this stuff over here. So to this side we will add negative 3x plus 4y. So on this side we'll add this stuff, and on this side we'll add 12, and 12 and this are the same thing, so we're doing the same thing on both sides. So 8x plus a negative 3x is going to be 5x. And here is the elimination part. Negative 4y plus a positive 4y will be nothing. It'll be 0y equals negative 32 plus 12 is going to be negative 10. I want to say negative 10. Negative 20. Pardon. Okay. Arithmetic is tricky stuff. So now we have 5x equals negative 20. And we're going to solve for x now. Divided by 5 on both sides, x is negative 4. So there is half of our answer. We need to find the y value as well. And remember, this is the x that's going to work here or here and give us the same y, so we can put it into either equation and find out what y is supposed to be. I don't really like negatives, so you have to choose one to be negative, so I'll choose this one. I'll choose negative 3x. Oh, x is negative 4, so negative 3 times negative 4 plus 4y equals 12. And negative 3 times negative 4 is positive 12, plus 4y equals 12. Subtract 12 on both sides. 4y equals 0, so y is 0. So the solution is negative 4, comma 0. There's your solution. Okay. In the sample problems, we'll see examples of where we get no solutions, infinite solutions, using both the elimination and substitution methods. And so we'll see what that looks like in the following video. Thanks for watching.